Good morning. So today we will discuss about the oscillators. After I completed the feedback amplifiers, now we are going to discuss about the oscillators. The first oscillator we will take a RC phase shift oscillator for discussion. So oscillator fundamentals. Oscillators are basically a positive feedback amplifiers where the feedback signal is going to add with the existing signal, and the feedback loop gain formula AF equal to A by 1 plus beta A. So here the denominator has 1 plus beta A, where beta is the feedback factor and A is the gain of an amplifier. So definitely the output gain is going to be increased. Okay. So to oscillator, generally it is going to generate some waveform continuously with the input DC biasing. With the DC power, it is going to give you a continuous waveform. So it can generate a different frequency component, and it can generate different kind of waveforms. Either it may be a sinusoidal and non-sinusoidal signals, maybe a square or a triangular or a sawtooth. It can generate different kind of waveforms that we call it as an oscillator, and it is also creating some periodic waveform. After some time period, you are going to have same amplitude. So that is the objective of the signal. So where we can use this oscillator means we can generate some timing circuits, we can generate some moderating signals, we can generate some clock signals. So many places we will use them oscillators. So oscillator Barkhausen criterion. So beta A should be equal to 1. So that is the first condition. The unity gain loop for sustained oscillations, the magnitude of the loop gain, that is beta A, must be equal to 1, and the phase shift should be 0 to 30 degree, 0 degree or 360 degree. So total phase shift should be 0 degree. And in practice, the lot of losses are happening in the circuit. So beta A should be greater than 1. The magnitude of beta A should be greater than 1. So first we will take a feedback network. So oscillator we can classify into two categories. So it will have one particular part is called amplifier path, and another part is called feedback path. So that feedback path in RC phase shift oscillator, you can have some resistors and the capacitor combination. So this is going to create or generate some oscillation, and this is going to generate some phase shift also. Okay. So the amplifier part is just to amplify, and feedback path is responsible for oscillation. So in this circuit you can see you have a 3 RC combination, that is one RC network and second and third. Totally we have 3 RC networks. So this RC network, each RC network can create 60 degree phase shift. So total put together 180 degree phase shift, and the amplifier is going to give another 180 degree phase shift. So total of 360 degree phase shift can generated by this circuit. So the oscillation will start like this. So initially when we switched on the circuit, the noise signal will enter into the circuit. So the circuit is going to select one particular frequency which is designed for that. So initially the amplification building up, and you can see that the oscillation is sustained oscillation. You can get it after some iteration. So we can use a transistor. Either case we can use an op-amp or you can use a transistor, both for amplifier purpose, but the feedback is remains same. So you can design oscillator using a transistor as well as operational amplifier circuits. So what is the frequency of oscillation for this? The formula is F equal to 1 by 2 pi RC root of 6 plus 4 of RC by R, or generally 1 by 2 pi root 6 RC. Okay, if R and RC are same, you will have a root 6 RC. Sometimes the RC value is very higher and R is minimum, we can neglect it. To sustain the oscillation, transistor gain must be greater than or equal to at least 29 times. The actual formula is HFE must be greater than 23 plus 29 R by RC plus 4 into RC by R. Based on the R and RC value put together, minimum of 29 times the gain is required. The amplifier should amplify the input signal and output signal. The ratio should be 9 times the AV voltage gain. We can use either op amp or we can use either transistor. What is the advantage is excellent frequency stability and generates a pure sine waveform, and applications widely used in audio frequency ranges from 20 Hz to 20 kHz, and the limitations R and C values are very low, so we cannot generate very high frequency. That's all about the introduction to RC phase shift oscillator.